There is something in human life that is more valuable than all the wealth in the world. That thing is time. If you lose money, you can earn it again. If you lose wealth, you can rebuild it. But once time is gone, nothing on earth can bring it back. Today, we wake up and check the time on our phones. A watch tells us the exact hour and minute. Computers, satellites, banking systems, and modern communication networks all depend on incredibly precise time. But humanity did not always have this luxury. Thousands of years ago, people had to look at the shadow of the sun just to estimate the time. They measured time with flowing water, they used burning incense, they even watched grains of sand fall through glass. And today, humanity has created clocks so precise that their error can be incredibly tiny even over billions of years. But this extraordinary journey began thousands of years ago. So how did humans first learn to measure time? What did the first clocks look like? And how did we go from watching shadows in the sun to measuring time using atoms? This is the extraordinary history of the clock. Around 4,000 years ago, ancient civilizations were already using one of humanity's earliest timekeeping technologies, the sundial. The idea was remarkably simple. A stick or vertical pillar was placed on the ground. As the sun moved across the sky, the shadow of that object moved as well. By observing the position and length of the shadow, people could estimate different parts of the day. When the sun was high in the sky, the shadow became shorter. As the sun moved toward the western horizon, the shadow became longer again. Humanity had discovered something extraordinary. The shadow of the sun could become a natural clock hand. But there was one major problem. What happens when the sun disappears? At night, the sundial was useless, and on cloudy days, it became far less reliable. So humans began searching for another way to measure time. In ancient China, people developed another fascinating timekeeping method, the incense clock. It looked somewhat like incense sticks, but its purpose was completely different. Incense was designed to burn at a relatively predictable rate. As the incense burned, people could estimate how much time had passed. In some versions, strings or small metal objects were positioned along the incense. When the burning incense reached a particular point, a string could burn through and release an object, creating a sound. Without looking at the sun, people could know that a certain amount of time had passed. It was an ingenious solution, but humanity still wanted something more reliable, and that search led to another remarkable invention. The ancient Greeks developed another important timekeeping device, the water clock, known as the clepsydra. Its basic principle was simple. Water flowed from one container into another at a controlled rate. Marks on the container indicated the changing water level. As the water level rose or fell, people could estimate how much time had passed. This was a breakthrough, because now time could be measured without depending entirely on sunlight. Day or night, as long as the water continued to flow, time could be measured. But there was still a problem. Water did not always flow at the same rate. Temperature, pressure, and the changing water level could affect its accuracy. So once again, humans searched for another solution. Instead of water, people began using sand. And from this idea came the famous hourglass. Two glass chambers were connected by a narrow opening. Sand slowly flowed from the upper chamber into the lower one. The time required for the sand to completely fall became a measurable interval. Hourglasses were simple, portable, and useful, but they had one obvious limitation. Once all the sand reached the bottom, someone had to turn the hourglass over, and if that took too long, the measurement could become inaccurate. Humanity needed something different, a clock that could keep running by itself, and eventually, that need would lead to one of the greatest breakthroughs in the history of timekeeping. By the late 13th century, Europe entered a new era of timekeeping. The age of the mechanical clock was beginning. These early clocks used weights, gears, and mechanical control systems. A heavy weight would slowly descend under gravity. That energy was transferred through the gears, but the gears could not simply spin freely. Their movement had to be controlled. This is where the escapement mechanism became crucial. It allowed the clock's mechanism to advance in controlled, regular steps. For the first time, mechanical systems could turn the continuous force of gravity into a regular rhythm of time. These early clocks were enormous. They weren't designed to sit on someone's wrist. They were installed in towers, especially in churches. Large bells would ring at specific intervals, allowing people throughout a town to know when it was time for prayer, work, or other important activities. The clock was no longer simply measuring time. It was beginning to organize human life. During the Renaissance, science and technology advanced rapidly, and clocks began getting smaller. The enormous tower clock gradually became a device that could be carried. Wealthy people began using portable and pocket watches, but there was still a major problem: accuracy. A clock that loses or gains several minutes every day can become seriously inaccurate over time. Humanity wanted a clock that could keep time much more precisely. And then came a breakthrough that changed everything. In 1656, Dutch scientist Christian Huygens built the first practical pendulum clock. Its secret was a simple swinging weight, the pendulum. The pendulum swung back and forth in a regular rhythm. That predictable motion could be used to regulate the movement of the clock. The result was remarkable. Pendulum clocks were dramatically more accurate than many earlier clocks. Humanity could now measure time with far greater precision. Not just hours, but increasingly precise minutes and seconds. But the world was changing rapidly, and soon time itself would become an essential part of modern transportation and society. During the 19th century, railroads expanded rapidly across Europe and North America. But there was a strange problem. Different cities often kept their own local time. Local time was traditionally based on the position of the sun, so two cities could have slightly different times even if they were relatively close to each other. For ordinary life, that difference might not matter much, but for railroads, it could be a serious problem. Train schedules became difficult to coordinate. A few minutes of difference could create confusion and increase the risk of accidents. The solution was the gradual adoption of standard time, and eventually standardized time zones. Time was no longer simply a personal measurement. It had become an essential part of modern infrastructure. As technology advanced, clocks became smaller and more portable. By the early 20th century, wristwatches became increasingly popular. The military played an important role in their adoption. During wartime, soldiers needed to check the time quickly. Pulling a pocket watch out of a pocket could be inconvenient in the middle of a battlefield. A watch on the wrist was much easier to read. When should an operation begin? When should troops move? When should different units coordinate their actions? Precise timing could make a critical difference. As wristwatches became increasingly useful, they eventually became part of everyday civilian life as well. The clock had moved from the tower to the pocket and finally to the wrist. But humanity still wasn't satisfied. We wanted even greater precision. So scientists began looking towards something far smaller than gears and pendulums. They looked toward the atom. Atomic clock technology began taking shape in the 1950s, and in 1967, the international definition of the second was officially based on the behavior of the cesium-133 atom. This was one of the greatest revolutions in the history of timekeeping. Time was no longer being defined primarily by the rotation of Earth, flowing water, or mechanical motion. Instead, the definition of a second was based on an incredibly stable atomic transition. That made atomic clocks extraordinarily precise, and this precision would eventually become essential to the modern world. Now comes an interesting question. When you look at the time on your smartphone, what does that time actually depend on? The answer is more fascinating than you might expect. Modern civilization depends heavily on extremely precise timekeeping. GPS satellites need highly accurate clocks to determine location. Telecommunication networks depend on synchronization. Scientific experiments require precise timing. Financial systems and computer networks also rely on accurate timestamps. In GPS, even extremely small timing errors can translate into significant positioning errors. So when you look at the clock on your smartphone, you're looking at the result of thousands of years of technological evolution, from a shadow on the ground to atomic transitions inside matter. And then came the smartwatch. Today's smartwatch does far more than tell time. It can count your steps, track aspects of your sleep, monitor heart rate and other health-related measurements. Some devices can also estimate blood oxygen levels, monitor changes in body temperature, and track physical activity. Thousands of years ago, humans looked at the sun's shadow to estimate the time of day. Today, a tiny computer on our wrist can track time while also collecting and analyzing information about our daily lives. The clock has transformed completely. The journey isn't over. Thousands of years ago, humans looked toward the sky to understand time. Then, we learned to use the sun's shadow. We measured time with water. We measured it with burning incense. We measured it with falling sand. Then came gears, weights, and mechanical clocks. Pendulums made those clocks more accurate. Railroads forced societies to synchronize their clocks. Wristwatches brought time directly onto our bodies. And eventually, humanity reached into the atomic world to define time with extraordinary precision. But this isn't really just the story of a clock. It is the story of humanity's desire to understand something we can never stop: time itself. We cannot stop time. We cannot buy it. And we cannot bring it back once it is gone. But over thousands of years, humanity learned something remarkable: how to measure it. And today, almost every major technology around us depends on that measurement. The clock on your wall is ticking. The clock on your phone is ticking. A satellite is carrying an incredibly precise clock around the Earth. And somewhere inside a laboratory, an atomic clock is measuring time with unimaginable precision. A simple clock may look like an ordinary object, but behind those moving hands is a story thousands of years in the making. A story of science, a story of invention, and above all, a story of humanity's endless attempt to understand time. This is the history of the clock. If you enjoy stories about the inventions that transformed human civilization, subscribe to Tosma Universe and turn on the notification bell, because our next story may be about another invention so important that the modern world would be almost impossible without it.